So we are being recorded, and you came to the third BrownBag session of EPAM blockchain community. We are still waiting people to join, and we'll give them another 2 minutes, and in 2 minutes we will start our program. By the way, everybody, welcome. I can see quite some people, and we are expecting more. So we are glad that our today's topic gets this audience. I think not to lose the time, but still wait for the people, we can give a brief introduction of our speakers today. Myself, I'm Sasha Petkevich, and I'm leading EPAM blockchain community, and I'm responsible for the blockchain business at EPAM. Today, I'm accompanied with two nice ladies from Quality Assurance Department. They're professional testers. And Nastya and Ira, could you please briefly introduce yourself? Nastya?
Hi, I'm quality assurance engineer, and I'm really happy to be part of our blockchain testing community.
Ira?
Okay, hello everyone. I am Irina. I am software test engineer, and I am really happy to be with you. Thank you.
Okay, we are slowly starting, and to conclude the introduction, the ladies are the active participants of our blockchain community, and they're doing a lot of testing activities there. And please don't judge strictly today, because the work we are presenting today is our half-year experience, where we decided to build a methodology for blockchain testing. During this time, we did quite some researches, tries, sometimes fails. But today we will share the topic, and please consider that as an introductory topic, because we do have to say more over test automation, over performance testing, but to bring our audience to a certain level, we need still to teach you the basics. And therefore, I will start with the basics. Give me a sec. I'm going to share my presentation, and please confirm that you can see this.
We can see.
Yes, we can.
Perfect. So, why the heck we actually started with the testing topic? Well, for the excuse, it's not the first BrownBag session. We were speaking about different topics before, but one of the important subjects for us was always testing, because when you deliver something, and especially when you deliver something in a blockchain space, the quality of application you deliver is very, very important. We will go through the details and through the importance further, and we will explain all of this stuff. But I would just like to remind you two things which happened in the past. I'm pretty sure that everybody here on this call ever heard about DAO case. And DAO was one of the brilliant, I would say, very interesting ideas within Ethereum space, decentralized autonomous organizations. There was a lot of business logic, a lot of value behind, but unfortunately, like one day after go live, this all explode with the massive amount of funds transferred out of the system and hard fork of Ethereum network. You probably know that there are now two Ethereum cryptocurrencies. There's ETH and ETC. And this hard fork and this division of the network for two pieces was a result of the stupid bug in the DAO split function. And if the necessary attention to the quality of the code would be given, that would never happen. But yeah, as you know, Ethereum network had survived with some losses, I would say, definitely losses. And like the most remarkable was the loss of the reputation. Because nowadays, very frequently when I'm presenting to the businesses, they don't understand what happened. They don't but they heard about the DAO case. And when you are presenting on a business level about use cases, about the importance of the decentralization and blockchain solutions, they all have the question, but what about the DAO? And yes, you have to explain them the details. You have to bring to their level of understanding what actually happened and why it would not happen again with their particular solution. Another case, also pretty much well known, where 2 years after start of Bitcoin network, one of the Bitcoin developers were just looking to the transaction log and saying, "Oh, what the heck? It's a pretty strange transaction," was the message, and that appeared to be that well, that was the version of Bitcoin 0.8, and it appeared to be that it contains a stupid bug, which is number overflow. I guess testers and developers on this call, you understand that well. But as a result of, again, stupid number overflow, the Bitcoin version 0.8 has to roll back to 0.7, and all transactions which happened in between, like basically during where the version 0.8 was working, they were just forgotten. And again, you can probably discuss the damage in terms of the actual money, but the damage in terms of the reputation was remarkable. And there were many, many other cases where the stupid mistake caused a lot of funds, a lot of money, and caused the loss of trust. And during the presentation today, we will explain, first of all, why the damage is such big. And we also trying to bring you to the stage of the understanding why the testing is so important and how to approach the testing of the decentralized systems. So we will start with the very, very brief, and please excuse us, we cannot be sure every time when they are presenting that the people joining know what the blockchain is. So every time we're spending about 5 minutes explaining to everybody what the blockchain is. We hope that after several years, we will stop doing that because the whole world will know what the blockchain. But for today, we have to spend this. Then we will explain like how the nature of blockchain affects the testing work, how the specific requires the special QA approach. And then we will speak about the practical applications and we'll speak about some tooling, but that's the top of the iceberg. So starting with the blockchain overview. Not to tell everybody that the blockchain is a chain of blocks, we will better start at saying it's a distributed ledger. And this distributed ledger maintains copies of the data across the decentralized network, such like every node contains the full copy of the ledger. And the transactions in this ledger, they are concluded among the consensus in between nodes. There are different topologies of the network. There are different algorithms, how the transactions are picked up by the pool, or how the nodes are awarded the right to add transaction to the chain. This all depends on a particular technology, but the main things are decentralized network, copies of the ledger shared among the nodes, where each node contains a copy, and there is a sort of the consensus, and the algorithm used for consensus can also differ, but there's always some approach to achieve an agreement if transaction happened or not, if transaction valid or not. And the different blockchain technologies, they vary by the algorithms of consensus of how the network achieved the similar, well, not a similar, but exact understanding of the sequence of the transactions. And for the QA purposes, that's very, very important. Every working, every stable blockchain ledger, like every node in this ledger, has the same understanding of the transaction sequence as the other nodes in the network. And that's basically the algorithm of the particular blockchain technology, how that's achieved. And one of the main qualities of the blockchain ledger is, that's decentralized, that's immutable due to this chain of blocks. And it's basically, well, it's not always chain. In some cases, that's graph or tree, but it's certain structure of the blocks. And each new block contains some derivation of all previous blocks or just previous block. And normally people say it's a hash function of the previous block, which is embedded in the next block. Therefore, all the blocks in a chain, they're linked together, and that's very difficult. And normally it's named very expensive in terms of either computer power, either in terms of money to redo this chain, which leads to the immutability. And that leads to the very important quality of the blockchain ledger, which is called 100% auditability. We can always say what had happened in the past. As I already mentioned, nodes in a network have consensus mechanism to come to the certain decisions, to come to a certain conclusion. And there's a possibility to run business logic within a network. And most people call that smart contracts. Actually, a smart contract term belongs to Ethereum network, and in many others it's called on-chain code. But yeah, for the simplicity, we used to call that smart contracts for the networks. And also, blockchain ledgers are normally fault tolerant. What value that brings for the business? We might have business people, not technology people on this call. First of all, that brings trust to the parties who are looking at those databases. And when we are speaking about trust, we are saying that the business can be sure in the data they're looking upon, because it's exact the same data over the whole network. Like in integration cases, they look into their own database and have to believe that the data in databases of suppliers or partners are kind of similar or correlated. In the blockchain case, they're looking at the exact data which exists in the system, and they know that their partners who are working within this network have the same data, which builds trust. That also brings auditability, because first of all, at this particular moment, you know what the data is, and in any moment in the past, you know what the data was. It brings a certain security, and basically, normally in a blockchain ledger, every party participating is identified by the number of crypto keys, and all the communications are encrypted. There are quite of some in form of smart contracts. We bring a lot of automation for the business. For many business people, we are saying that the blockchain solutions is a way to automate managerial decisions. And also because of the decentralized nature of the network, that's high availability networks. You are not anymore dependent on availability of the particular data center or the particular piece of the network. I wouldn't spend a lot of time describing and comparing that with the traditional ledgers. You have that on a screen. I'm pretty sure that you know that. So I would like to move to a little bit to the history of blockchain, which I guess a lot of people know, but let me spend another minute on this. The goal of this is just to explain you that the technology is pretty much new, very, very new. In 2008, there was like a famous paper of Satoshi Nakamoto, which combined a lot of well-known technologies like hashing, like encryption, all together. And the Bitcoin was kind of created. In 2013, and again, the technology would never fly that high if in 2013, Vitalik Buterin wouldn't come with the idea of a company, with the idea of the smart contracts, with a company, the cryptocurrency and the value transfer over the network with the possibility to run the business code. And starting from 2014, 2015, a lot of major technology providers like Microsoft, Oracle, SAP started to look at the technology. In 2016, the business adoption had started. Banks have announced blockchain solutions and the fact that they're experimenting blockchain, supply chain, logistic companies. But at the same time, because we're speaking of testing, the whole history of the development of the blockchain technology was associated with bigger or smaller failures. I already told you about Bitcoin problem, which happened in 2010. Then in 2011, there was a guy who alone, like almost alone, developed the cryptocurrency exchange where there were mistakes and the money was stolen, not only from him, but also from all his clients. Then in 2016 was a DAO attack, and there's only major problems, and there are many of them. And basically, blockchain technology really asks for the good testing, and at the same time, that's probably less mature than majority of the technologies used today, and it's pretty complex. So a little bit again about a smart contract. That's the first of all, the smart contract in a network. It's stored in a shape like what almost the same as a transaction. That's the same consensus is necessary to apply the smart contract in a network, and that's appear to be the part of the chain, and it has an address. And contracts are immutable, which means that to install the new version of the contract, like you can do that, and it would be new transaction on top, it would be new block in a chain, and the most important, it will have new address, which means that all the previous history of like previous version of the contract needs to be migrated along with the balances, which is normally a costly operation. That's important. It's important that when you deploy the smart contract, being deployed, it's appeared to be immutable. And if it has bugs, you need to migrate everything, means all the references which are done for this particular address and all the transaction history from this contract to the new contract version, to the new contract address. Then going further, another bit of the wisdom, blockchain networks are not always private, not always public. There are a variety of them. And we normally say that there are two dimensions. The network can be public and private, and that speaks about the ability to join the network. For example, majority of the cryptocurrency networks like Ethereum, Bitcoin, they're public networks. You just need to install the software, but you don't need any invitation or something. You can just... The majority of the enterprise grade networks, they are private networks. You have to get invitation. You have to get invited, or you have to have the special setup procedure to join the network. And the second dimension, the network can be permissioned or permissionless. And that normally speaks about what you can see and what you can do in a network. And for example, Ethereum is a public permissionless network. You can see everything and you can do everything. Majority of the enterprise networks, they are private, and the consortia is a set of the private networks. And they're permissioned because you are defining what participants in a network are able to see In most cases, businesses demand that, and what they can do. So let's look to the typical blockchain solution, which is, again, it's a software solution. It's like no magic. It's done by the same people, by the same type of the developers. You probably need to know more libraries, more tools, better understand the centralization. But at the same time, it's still software product. Where, like, to design a software product, you normally need solution architect. In our case, you need blockchain solution architect to understand all of the aspects. If particular solution has a user interface or interact and is a part of the scope, like decentralized applications or something, you normally need UI developers, front-end developers, and obviously you need backend developers. On this slide, it's called blockchain developers. Normally when we say that, we mean backend developers, the guys who create the solution itself. If you like, one, none of the solutions exist in a vacuum. You normally need to get the data. You are normally requested to provide certain interfaces to the data you have in a system. So you need integration developers. And obviously, to have all the development smooth, nice deployments, accurate, you need DevOps or cloud architecture guys or cloud development guys. Basically, you need somebody who thinks about your infrastructure. And then, guys, about what we are going to speak today, you need testers. You really need people who validate your solution and who tell you that your solution works, first of all, according to your requirements. Second, according to your non-functional requirements, means the behavior of the product you are creating is as expected. And that the solution itself, it satisfies the architecture principles which were put in a basis on the design phase of this solution. And that's important. It's important that while we are doing, like, we are not only testing according to functional requirements, we have to satisfy that the blockchain qualities which are expected as given, they're satisfied. And we are moving further. All the introduction is done. And let's see how this non-magic but software decentralized solutions, why do they demand a special approach for the testing? And here probably Ira will help me. Yeah.
Yes. Okay. First of all, I would like to underline that blockchain bring huge challenges in testing world. And let's focus on the top key challenges. The first point will be understanding the technology. Blockchain is new technology and needs to be understood in depth before adopting blockchain as a technology. Technical expertise with domain knowledge is very important in testing blockchain application. The second point will be lack of blockchain testing tools. Testing blockchain is all about tools. If you don't have the right set of tools, you are likely to fail. Testing blockchain application requires a mixed tool set. Pick up the right tools as per the application is crucial decision. This point we will consider later. Next will be lack of best practices. As you already know, blockchain is new technology and we face with lack of experience in development blockchain applications. This is one of the biggest challenges in the blockchain space. Blockchain technology was first introduced in 2008 by Satoshi Nakamoto in the form of Bitcoin. However, it has not been adopted in the industry due to a lack of experience or skills. This makes testing a challenging task. Regarding test strategy, like any other applications, coming up with test strategy for blockchain technology requires a deep understanding of the application, its usage, and the technology itself. Let's move on the next point. This is addition of blocks. This is very important point. Please keep in mind, when we add a new block in the chain, we have a new state for all our system. And if we find the defect, we don't have any opportunities to reproduce this case with the same preconditions. We cannot reduce. We cannot return the system to the initial of the state. We cannot update or delete the completing transactions. Blockchain technology is meant to be used to store and process huge amount of data. It means that a lot of test cases to be considered. That will bring us to our next point. This is block and chain size. Testing the size of the blockchain and chain is an important aspect for the blockchain application. This requires a proper validation of the data being added. Block size. A block contains real-time ledger record with inscription and timestamp. There are groups of transmission which are confirmed and then shared on Bitcoin's public ledger, which is the blockchain. In current time, we are focused on multiple questions, such as what if the transaction size goes over the defined size? What tests should be considered if there are multiple transactions in a block? And many more scenarios. Chain size. The chain size practically can be many blocks at the chain lengths. Testers should verify that chains are not broken at the time of testing. It's very important. Verify that a complete record of transfer is tested under possible scenarios. Let's now talk about transmission of cryptographic data. The main crux of the blockchain technology is the transmission of encrypted data. There is high risk of failure. Testing around data loss during transmission is carried out. The peer-to-peer architecture of blockchain deal with data encryption at source and decryption at the receiving end. Testing for transmission ensures minimum data loss, improved process workflows between peers. Sasha, could you please next slide?
Yeah, I will just quickly summarize that. Just, guys, you heard about all of this complexity, but just for a second, imagine that you need to test the technology, which is pretty new, which is like rare to find the people who really understand how does it work. At the same time, it has ridiculous limitations of the code size, of the number of parameters you can get in a function, all those block and chain sizes. That brings a lot of ridiculous limitations, and normally if you use to automation testing or if you use to embed stuff in a code to do the testing in the future, and even for the unit tests, you normally, like for the contracts, for the big contracts, you don't have enough space, you don't have enough parameters, you do not, and on top of that, everything is encrypted. And every time to send something, you have to encrypt and decrypt, and not to be mistaken in a pair of keys you are doing this. And well, for poor tester, comparing to like usual applications, it's pretty challenge. And Ira, please continue.
Thank you, Sasha. Let's switch to integration testing challenges. Integration testing, it's about ecosystem. The word ecosystem was originally a biological term used to describe a group of organisms interacting with one another. When we talk about blockchain ecosystem, there is the groups of actors interacting with one another within the world of blockchain. In our typical blockchain, actors include users, miners, developers, and more. The core interaction between these actors take place in the form of transactions. But these transactions are limited to the blockchain itself. To ensure the ecosystem fulfills their purpose, they are often controlled, including the creation of application, integration with external systems, and more. Hence, integration testing must be carried out frequently to avoid any failures. The key responsibility is to ensure that the response from all interfaces is consistent and there are no disconnects. Security testing. It will be next point. Security testing is another aspect of testing blockchain application. As mentioned earlier, securing the data should be the high priority. Blockchain technology can be used in various sectors like health, banking, finance, education, and any kind of security breach would lead to a huge loss. As a company, we need to understand that blockchain is also not completely secure and take steps to make it safe. There is represented the list of more popular the type of security risk, such as human-related risk, risk with private and public key, vendor's risk and untested code, and lack of standards and regulation. For example, risk with private and public key. The whole idea of blockchain or distributed ledger technology relies heavily on the public and private keys. These keys are a series of characters that offers unique security properties. One security property is that is tough to guess. Blockchain work with these keys. If you don't have the right combination of the public or private key, you cannot access the digital content stored within blockchain. For example, vendor risk and untested code. Many ad hoc platforms and services work with distributed ledger technology to improve its functionality. With TLC growth, it's evident that we will also see growth in third-party development. There include solutions such as wallets, payment processors, smart contracts, blockchain payment platforms, and so on. The quality of the code remains a big concern to most of the blockchain solutions. Decentralized organizations need to take extra care when they deploy their solutions. One of the primary blockchain security issue is the lack of regulation and standards. There are no major standards addressing distributed ledger technology yet. The absence of international standards carries risk related to customer lock-in, lack of interoperability, privacy, and security. And then, performance and load testing. Performance testing in blockchain is important because of the number of transactions and transaction size being tested for the performance of a block. The testing team focuses on other important and dependent parameters, such as network latency, performance bottlenecks, the sequence of transactions and at every node, also dependency on the production environment, transaction processing speed, client user and system interface, along with the responses required from the smart contracts. To conclude, like any other application testing, blockchain application is also requires the right set of skills and understanding to come up with a test strategy. Most importantly, non-functional testing becomes a key challenge here.
And here to conclude, you heard from Ira what needs to be tested. And we will go deeper, like on the next slide, you will see the very interesting, I would say, well, I wouldn't tell that another minute, but what we would like to say, that we would like to say that currently, due to immaturity, due to novelty or high novelty of the technology, the existing test solutions, they does not really help. First of all, environment management is disaster. Try to imagine that every transaction in the blockchain system that evolves the system itself. Like, okay, transaction is added to the chain, and that's not possible to roll it back. This is a very transaction that's added, and you, with your test environment, went to the new stage of your test environment, and you cannot roll back. And if you would like to roll back, that will require a lot of technical stuff to get the same version of the chain which was before this transaction. Then again, encryption and all the maintenance of the keys, because you cannot test without encryption. Everything is encrypted. And you have to run all your tests providing the necessary keys for encryption and decryption. And also, blockchain, due to this decentralized network stuff, needs, in some cases of testing, you need to have this holistic view. For example, you need to have an overview how equally the transaction distribution over the nodes. Or you need network, like what you need, like infrastructure data of how quickly transactions are reaching nodes and how quickly databases on each node are updated. You have to have the statistics which, well, you are testing centralized applications you never come upon. And as the majority of the testing software were built to test centralized systems, you either have to use the new specially created for the tools, which are also buggy and which also have the limits in the functionality. Either you are building that yourself. And on top of that, all the complexity which Ira shared with us, all this lack of knowledge, lack of the resources, then ability, you're probably familiar. A lot of people say that the blockchain is a technology for engineers, for programmers. And therefore, like all the problems, all the bugs in the past I introduced you to, they were because majority of the creators of those solutions, they believe that a developer is enough to test, which actually, like, the real life proves us that, sorry, it's not. So, the whole world, and being a part of this world, EPAM, and also delivering blockchain solutions. At EPAM, we do have blockchain solution being live now for more than 2 years, Sigma Ledger. And we had to test that. We had to upgrade that. And basically, our life and circumstances in this life brought us to the situation where we started to think about the specialized blockchain testing, where we started to think about professionalizing blockchain testing delivery, because we need to be sure that the solutions we create for our customers are good quality. And let's look to our testing framework. And I'm inviting Anastasia to speak about like top levels, I would say. Remember, today we are doing introduction, so top levels of the blockchain testing.
Thank you, Sasha. Well. Is it really so hard and so many challenges around the testing blockchain? Surprise, surprise, it's really not magic, as Sasha told, and it's still software applications. We already have a traditional V model, and I'm sure that most of you can recognize this picture. So the basic testing principles are the same as for traditional software. We can just take this model and use it for blockchain projects, but testing of blockchain-based applications has its peculiarities. And first of all, we have a unit testing. And if we are talking about blockchain, it should be smart contract unit validation, transaction timestamping testing. And so what does it mean? It's a computer code expressing one or more business logic. Usually, unit testing it's a developer's responsibility. Move on. Main tester's responsibility is a component integration testing. Usually, it's a testing of business rules through smart contract, node consensus validation of transaction, and depends on the project. QA team should cover the main business rules, anticipate the most of risks. The main goal is prevent, pay attention, and analyze how system should work in the all unusual situation. We should predict all negative cases as early as possible. Because, as we know, the cost of failure may be too high. Subsystem integration testing, it's also QA specialists have to check and keep in mind relationships between all parts of system. For example, shared ledger database, events or notifications, API, access control, payments, etc. Talking about system integration testing, it's a good point to have a performance and security specialist. To test load testing, wallet signature testing, scalability and stability, and transaction processing, etc. On the acceptance testing, we can test UI and mobile application interface, transactions verification, and sign-in. What is necessary that on this stage of testing, it's a good question what environment we can provide for customer to test blockchain system. What environment we can provide for users, especially if it's an open source blockchain systems. We need to learn how to work with a production environment that is out of our control and poorly predictable. Next slide, please.
Just a moment, which I would like really to stress the fact on those environment management and actually the test management here, because the majority of the blockchain solutions, as you probably know, they are either ecosystem or community based. There are a lot of stakeholders, which are normally either different legal entities or different individuals, which brings us like even like a relatively simple concept of the user acceptance testing started to be very complex ones, because when you have like ecosystem of the companies who are building the solution, first of all, they do have ecosystem of the requirements, and probably importance of the requirements for the different participant can be different, and the understanding of the system behavior, because in some cases, the parts of the ecosystem, they expect slightly different functionality of the solution, and therefore slightly different versions of the code, different dApps, in some cases like different wallets. And it still needs to be tested as a one system. And it needs to be accepted as a one system, which means that the acceptances of their separate like parties needs to be concluded as the overall acceptance of the solution. And here we are coming to the governance topics. And therefore, the whole governance of the blockchain solution needs to be tested too. So all like when we're speaking about the non-functional requirements, maintainability, all this durability, all the ways how we upgrade the solutions, how we are rolling from one version to another version, how we are doing the data migrations, all of this needs to be tested. And because of the multiple stakeholders, multiple parties involved, we are getting the additional dimension in our testing. And this additional dimension needs to be managed. Yeah, we are moving further. Yeah.
And so, as we can see, for any project, it's a good point to discuss responsibility areas. For blockchain projects, it's also so important to prevent some stupid issues, for example. It's important to know which team should track a quality of product in each of testing stage and in each of testing type, and what environment can be provided for testing needs. And if you talk about open source project, we need to think about user expectations and user experience. Here, I think the skill needed is an ability to predict how the user will interact with applications, understanding of the UX concepts. We described role and responsibility on the master blockchain test plan. There you can see more information about responsibility areas. Let's move on to our next slide, please.
One more just to conclude and to clarify to the people who do not know, master test plan is what we have, like we have the framework for blockchain testing. And probably on the next session, we will introduce you, because basically this high-level concept is described in a set of the tools and the documents. And the master test plan is the document for the test manager who are leading testing at a blockchain project, which is describing responsibility of the parties, which is explaining activities, explaining test strategy, environment, and test data strategy, and what approaches to that. Because the test manager is actually designing that, but we are providing the person the necessary aid. And when Nastya was speaking about the different teams, I would like again to stress that in the blockchain solutions, in most of the cases, these teams appear to be team of teams or community. Either you have development community where you have where you do the community-based solution, where you do ecosystem, you normally have several teams of the developers, several teams of the QA engineers, several business teams. And every time you speak about team of teams and about governance in between of them, and this also needs to be tested. So, Nastya?
Let's discuss key points to focus your testing efforts on. It's a functional testing, traditional non-functional testing, and testing specific to blockchain. And I describe it on the next slide. Thank you. Firstly, it's a functional testing. Generally, it's a basic testing of the components and system. Testing is undertaken with respect to use scenarios, main use cases, requirements, and specific business processes involved, including integration testing. It tests the integration or interfaces between components and different parts of the system. With blockchain being deployed in various systems and environments, integration testing ensures consistency in performance critical to the flawless implementation of the blockchain. So functional testing.
And here, just 1 second. And here we are when we are speaking integration testing, here we are underlining, meaning this off-chain, on-chain, because you probably know, due to various limitations, we cannot, and the limitations are technical and non-technical, both. We are not always can store all the data on-chain, which means that we're forced to keep the pieces of the data off-chain, which introduces the integration in between. And that's why we probably see the integration testing as standard validation, because that's appeared to be the part of the functionality. Also, that's very important to mention that while we are doing the functional testing for the blockchain solutions, that's the same important as to test the positive flows to test the negative flows, because the negative flows, the error handling, that's the area where the majority of the vulnerabilities of the blockchain systems were found. So the majority of the problems and the situations where blockchain networks were hacked, or where the behavior was working not as expected and where the intruders got in, were through the error handling or unexpected behavior of the applications. So testing, like even doing the standard functional testing for blockchain solution, we need probably to do that on non-very standard way. We'll need to put a lot of emphasis of testing of all the exceptions, like our error handling is complete, stable, and effective. Nastya, back to you.
Yes. And secondly, it's non-functional testing, which consists of security testing. Is essential to blockchain application debugging, as blockchain funds using highly secure financial, government, and regulatory environments. Is the application vulnerable to attacks? Is the authorization well entrenched and robust? How well does the system protect data and maintain the objective? Testing for confidentiality, integrity, authentication, access, authorization, and non-repudiation are critical components of security testing in blockchain applications. And also non-functional testing consists of performance testing. It's one of the most important criteria of blockchain applications is speed. The performance and latency vary with the size of network and size of transactions. Performance testing is a critical stage of the testing life cycle, as it tests the speed of performance with a given workload and whether desired criteria are met. And what I want to add, it's so necessary discuss time and speed of transaction, because of course it will affect your testing routine, and it's so important to keep in mind and discuss as early as we can.
And a little bit about the performance testing on top of that. We all know that one of the main applications of blockchain solutions is IoT. That's very desired to use the blockchain technology to maintain information flows or transactions produced by devices. It's like business-wise, that's a huge desire. But you know, when you're working with the hardware, when you're working with the IT stuff, you need to maintain a certain speed. It's also what produced like higher requirements to the performance, and it also produces the higher requirements for the scalability, because when we're speaking about the devices, we're speaking not about one or two, we're speaking about like millions and trillions of devices. And that's like natural step, next step in a technology. That's why a lot of focus put on performance testing on the blockchain solutions. Back to you, Nastya.
And talk about peer node testing. Move on the next slide, please. Let's to clarify what does it mean. A node is a device on the blockchain network with the ability to carry out multiple tasks, such as send, receive, create, or store data along distributed network routes. When multiple nodes interact with each other, they are termed as peers that work the same way. Nodes talk to the network and acquire more details about the network through their peers. peer node testing is essential in maintaining the integrity of the network and shared ledgers. The power of blockchain applications lies in the shared ledger being precisely the same at each node, with exactly the same set and sequence of transactions. It is achieved through consensus across all nodes in the order in which transactions are added to the network, validated by regular testing, where nodes fail and fall concurrently or participate in the network within given time. Performance testing helps to validate the consensus. Do the nodes in the network sync with other validating peers? Is the integrity of the network and shared ledger mentioned throughout the testing? It's a good point to analyze relations between nodes. If there is disbalancing, do the nodes have a special settings? And so let's discuss the smart contract testing. Ira?
Yes, I can proceed. Okay. As Sasha mentioned earlier, the smart contract is a computer protocol that allows the performance of credible transaction without third parties. Smart contracts help you exchange money, property, shares, or anything of value in transparent, conflict-free way while avoiding the services of a middleman. At the core of the blockchain validation process is a smart contract. It refers to the set of software constructs that automatically execute transactions when predefined conditions and business logic are met. Testing smart contracts involves simulation of all possible expected and unexpected variables for every contract. In a given dynamic network, with vast numbers of nodes and probably combinations, automation of testing is significant. Besides this, smart contracts enforce a set of rules through strong cryptography, validation of inscription codes, and is also required used robust testing methodologies. Maybe you have questions, why is contact testing so critical to blockchain? When a contact is created, it's perpetual. So when a flow is discovered, a fresh version of the contact is created and deployed. When you do so, data stored in the previous contact has to be manually initialized in sync with the past state. Another problem that comes up is that of updating a contact or rolling back an update. It plays a huge challenge for the quality assurance and debugging team. The smart contract testing process begins with validation the method, the inscription and transmission. However, the most complex stage is validating the processing and execution of the contracts. Back to you, Sasha.
Yes, and now for me, because we are speaking about testing the various blockchain components and looking to the blockchain specific. First of all, blockchain solutions, at least when you are the company providing IT services, they differ. In some cases, like you really have different parts of the application scope, and you may be not the only technology provider in ecosystem. So I will try to outline everything which is possible, or at least which lays on the top, but not necessarily all the parts which I'm mentioning belong to every contract or every software development. That might be that you are developing dApps only, or when you are developing only foundation layer, or probably you are doing the integration project where you are connecting your client to the existing blockchain network. In all those cases, the content of your, I would say, test strategy or content of your test program, that will vary. So we're here thinking and speaking academically of what we can see. First of all, while testing blockchain solutions, which again, in most cases, shared ledger. And this shared ledger that's either transfers the value, either mutates the data. First of our attention needs to be transaction processing. We need to see that the transactions are final, means the whole network came to one decision over the transaction, if it happened or not. And the whole network reach the same decision over the sequence of the transactions. Then we when we are looking to the transaction which moves our system from one state to another one, we also need to achieve the proof of distribution that everybody in the network have received that. When and we also need to be sure that we don't have the parts of the network which are deliberately excluded from the transaction processing. And here we are coming to the area which is not easy to understand and not very common when we're speaking about the centralized solutions. Try to imagine that you have a huge network of the peers who are connected to each other. And basically, the network qualities in between nodes, they're different. And also the speed of processing transactions between nodes is different. And it might be that due to certain infrastructure issues, certain speed or something, the parts of the network are being disconnected from, I would say, the bigger part of the network where transactions are happening. And there are situations where the transactions are happening in disconnected parts of the network. Something like, try to imagine two subnetworks which are not intersecting, and the transactions which are happening in one part and in another part. And while the connection would be maintained back, we need to, the whole network to come to the same sequence of the transactions. And basically, while we're speaking about the development of the foundation layer, we have to model those situations, which is also not very easy. Very important when we're speaking about the testing, we're speaking about the blockchain solutions. When it's connected to the value, we are normally what the concept of the wallet or vault is introduced. It's where the users keep funds, tokens, something. And those wallets, those are the places which are being attacked and where we need to ensure that the data is stored securely, transmission securely, and that's interoperable. And in many cases, at the same network, we have different versions of the wallets, which and you need to assure the compatibility and data migration. Then I already spoke many times about blockchain governance, and that would be the topic which we will return in every aspect of working with the blockchain solution, starting from designing the solution, starting from the requirements management, which is also part of the quality assurance, actually. We will need to ensure that it's done properly, that the requirements are properly gathered by the various ecosystem partners, that they're properly described, that they're not controversial, and if they are, there is a way to achieve the certain, I would say, consensus or compromise in between so-called controversial requirements and the model chosen for the consensus and the possibility of the consensus. And we also, there's a term like when we have governance of blockchain solutions, basically description of management part of the ecosystem partners, in some cases, we are describing that in the terms of the smart contracts, where we are saying that we are encoding governance, and we are encoding governance, which is, and keeping that in the same chain. So in the same solution, and the relationships of the ecosystem partners, they're being programmed like the rest of the functionality. And that's probably the easy paradigm for you to understand that it needs to be tested. So obviously, every part which we are coding, we are testing. Probably the next step in your understanding would be that even if we keep governance off-chain, means in the terms of the legal contracts in between companies, it also needs to be tested, even if it's not a computer program. We have to ensure that the business network we are bringing live and the ecosystem, together with the software solution we are introducing to the end users, can survive over this certain time, which is normally the part of our non-functional requirements. But well, if for many people the coding part and the part of the on-chain governance needs testing is obvious, because yeah, like every code, I really would like for you to understand that even if your governance is off-chain, it also needs to be tested. Before going live, you need to test how you will come to the conclusion if the new version is a good version to be deployed, and how you will go through the deployment of the new versions and the data migrations, and how you will do like how the money, like how your crypto economy work, and how the disputes in your network work, being it programmed on chain or being that's done legally off chain. You need to test that. And then speaking about the platform characteristics of the blockchain solution, that's obvious that together with all the security parameters, you're testing your key storages, your identity services, you're testing the fullness and completeness of your APIs, and basically you are testing your UIs too. And in terms of the blockchain solution, it's the same as any other solution. You can have the different versions of the user interface. You can have different versions of the decentralized applications. When we're speaking about the wallets, you can have different wallets. And every time we're speaking about the ecosystem, community, platform, you always have requirements which needs to be satisfied, and you have requirements which are desired. For example, when you're testing user interface, obviously the party who introduced this user interface, because it can belong to the certain party, would be tested thoroughly by this party. But the certain parts of this interface, they are shared in between, or their functionality which is demanded by the network itself. And those needs to be satisfied and tested centrally. What, not centrally by the ecosystem, not by the only party introducing this DApp, but by ecosystem too. They need to be certified that they are allowed to work in this business network and allowed to work in this ecosystem. Well, I do hope that we basically reached the level where you started a little bit better understand what needs to be done and what types of the testing we are introducing and why it's so specific for the blockchain. And let's speak about the framework. We're actually trying to, at EPAM, to develop the framework for blockchain testing. And what we are trying to do, we're trying to develop this framework, but okay, not completely vendor agnostic, but at least on a principle level agnostic, means that having like three main pillars of Ethereum, Fabric, and Corda, and having like DevOps solutions for Ethereum, Fabric, and Corda, we would like to have test automation for our blockchain solutions. We would like to connect AI to that and to do the scenario extraction. And here we would say that when we would need to analyze the distribution of a network, we'd better get the data and to feed that to the certain AI framework, because it would be much easier to come to the certain conclusion and to see the similarities than to have a test coordinator staring at those piles of the data. We obviously would like to equip our testing framework with the industry-specific test cases or industry-specific diagnostic. Blockchain is normally implemented for the particular use cases. And currently, the top of those use cases is well known: supply chain, logistics, fund transfers, cryptocurrencies, or in some cases, energy trading. So the most obvious industry examples are well known, and every industry has standards. And we would like to have like those, like, I would say, middle level for our test information, which consists of those industry standards. And obviously, as every tester or every tester who is facing or who needs to answer the demand of the project and demand of the business, we would like to visualize our testing results and our testing progress, because like we all are testing professionals. We are the same as you, and every delivery lead, project manager, product owner, they need to understand the quality of the solution and the testing progress in the simple words. And when we are bringing such a complex aspect as blockchain testing, we need to be able to communicate it easily. That's why we would like to visualize that. And then we obviously, and that's actually our goal, and that's how we are developing our framework. We would like to share our knowledge about like the common bag, smart contract certification, or validation of the smart contracts. We would like to keep like the history of our testing, which is done for blockchain project, best practices, and we would like to share that because actually our goal within EPAM is equip all of our testers with the skills to test the blockchain solutions. Because here in EPAM, we do believe that our clients, they deserve the option to have their solutions decentralized, the same as centralized. It's like depending on the requirements, depending on the situation, but the options, like they have to be equal, which means that we have to be able to deliver that and to test that. And well, we're vendor agnostic. That's why we want to be flexible in our test delivery. We need to have our tools applicable for the many solutions and our methods to be applicable in almost every project situation. And we obviously would like to stay connected with our business analysts and developers, and basically do not have confrontation, but work together on increasing quality of the solutions we deliver. And here we're coming a little bit to the practical steps, and I do believe that Ira will help me with the blockchain testing tools we have in the market. We obviously, like in our daily life while testing, and we are doing that internally for our internal applications, we're doing that for our client, there are tools in the market already. We'd like to give you the brief overview, what is available by today.
Okay, now we come to the final phase of our presentation. This is blockchain testing tools. As you already know, blockchain testing is all about tools. If you don't have a proper setup and the right tools, you're likely to fail. As first you can see, there is a massive variety of tools that you can use for testing. It depends on the application and the blockchain platforms you use. For example, Hyperledger Composer. This is an open source development tool that contains many functions to help build blockchain applications. Also, this framework supports 3 types of testing: interactive testing, also automated unit, and automated system testing. The next tool useful will be Corda testing tools. Corda is also an open source distributed ledger platform that has a testing feature to help with writing context and flow tests.
Small
And
correction, Corda Community Edition. There is an enterprise Corda version, which is not open source, and you
No?
have to buy that. But it's just a small correction. There is an enterprise version of Corda, and it's being installed now in our sandboxes, but it's for EPAM, guys. We just installed that. We just got the evaluation package. But yes, there are two versions of Corda. Yeah.
Okay. Okay, let's now proceed to consider the test tools per network type. Next slide.
Yeah.
Okay,
Just
next.
give me. Yeah, I'm trying. Yes.
Test per network. Next.
Yeah, I think I already moved to the Bitcoin and Ethereum testing tools. Can you see this slide?
Yeah,
You
now
start?
yes. Yes.
Cool. Yeah.
Perfect. And we start from the Bitcoin testing tool. This is Bitcoin J. Bitcoin J is an excellent Java-based framework for Bitcoin-based application, and it allows you to interact with the real BTC network and test transactions. So also you can simulate send and receive transaction in real time. Turn to the Ethereum testing tools, namely to Ethereum Tester. Ethereum Tester is a pretty listing testing library that's available as a GitHub repo. And also, I hope this framework is open source and the setup is easy. The next will be Truffle framework. This platform supports testing feature in place such as automated contact testing. And at the end, Ganache testing tool. This is the most used library for testing Ethereum contracts, and you can develop your application and run tests. Moving on to our next slide.
I'm here.
Yeah, next slide. And the next slide presents the list of common tools used to the test a smart contract. Good, perfect. With Truffle framework, you already know, and now I would like to consider the Embark framework. This is another popular framework for building, testing, and development your app. Focuses on development of decentralized application that run on multiple nodes. Embark has integration with the Ethereum blockchain and a couple of decentralized communication platforms such as Whisper and Orbit. Well, that concludes our presentation for today, and we are talking about blockchain overview. What does it mean for testing and blockchain testing framework? Thank you for listening. And now we have time for questions.
Yes, guys. And currently, well, I switched my video on. Don't be surprised with the background. We are ready to answer questions. We do have a little bit of time, and as I already said, we try to give you glimpses of the methodology what we're using. We will try to keep you up to date with our automation, test automation, about the performance testing, about security testing, and well, I'm looking. We have twice a month BrownBag sessions, and this month the next session would be over business topics. We're discussing blockchain use cases for smart cities. Next month, we are going to have, again, one business and one technology topic, and probably we would be able to go back with the test automation case. I've tried to answer several questions in writing. There were questions from Thomas and with Daniel. And guys, if you have more questions, please shoot them.
I've got one more, Sasha. It's Daniel.
Yeah.
First of all, guys, thanks very much for that presentation. It was really insightful. And I think as an analyst, I've got a better appreciation now of all the complexity that's involved in the testing and things that I had not considered before. But one thing that I was interested in, a lot of what we're writing is obviously open. It's open source. It's kind of on a distributed ledger. It's there for everyone to see. And when it comes to the testing, how important would you say it would be to have third parties recheck and audit certain parts of your application? So, you know, so if there's a certain piece of logic that's out there, and we've done thorough testing, obviously this is going to be an open system with many participants, with many beneficiaries and parties. But you could just throw a lot of this code out and say, what I mean by that is you can say, come on guys, come and test our code because it's there. Try to find problems that we haven't found. So how important would you say that would be?
I will probably bring you the practical answer from like well-known projects or well-known world projects in blockchain. First of all, there is an institution of the smart contract formal evaluation or smart contract audit, which done again formally. And we as EPAM, we don't do this. There are special companies which are specialized in that. And every time when we are developing blockchain solutions and where the smart contract development on chain code is involved, we're always advising our clients to invest in a formal audition of the smart contracts. We honestly believe that it's not possible to go live without this, because those are mainly security audits and common vulnerability audits, and well, actually world community, world blockchain development community, well, that maintains the list of the well-known vulnerabilities in the smart contracts or like per technology actually. And the companies who do the formal audit, they're actually checking against each of them. We are doing our best, but we are not always up to the very recent situation. So the answer to your question, when we're speaking in terms of like smart contracts, we definitely recommend that. We also recommend to any of blockchain solution doing live to do the formal penetration testing. To do the formal penetration testing, like what formal security audit of the whole solution, and to get that validated by the client security department. And we normally do that with the collaboration of the client security department, their requirements, their ways. We are normally showing them the vulnerabilities we found and security breaches or something which we recommend them to look at, or when we recommend to developers. And that's normally maintained over the years, because well, when we find like the huge bugs, they solve before go live. But there are, you know, imperfections, and those imperfections needs to be worked upon. And that's maintained as like lifelong together with the project. That's improving, that's retesting. And normally like every year, like security audit for big solutions is done like every year, if not frequently. Also, for ecosystem-based solutions, the good practice is to separate the development and quality assurance. That's why we are also strengthening the blockchain testing aspect at EPAM, because we do expect the number of contracts where we do on the quality assurance, where ecosystem comes to us not for the development services, but for QA services specifically. Because for ecosystem, that's very beneficial to secure the quality of their ecosystem development. Again, remember, that's not one company developing. That's team of teams. That's ecosystem of the developers, ecosystem of the architects, and the solution which appeared to be it gets complex, and I guess qualities of like which brought there by multiple partners. And that's why it's really beneficial for them to avoid the quality assurance implementation to another partner, just the independent one. Did I answer your question, Danielle?
Yes, you did, Sasha. Thank you. That's great.
Guys, more questions? We also have guests who are outside of EPAM. Guys, don't be shy. I do believe that it might be my important topic if you shared this presentation. So ask questions. Seems we are good in giving answers. And normally, when this type of like brown bag presentations, when we don't have a lot of questions, I'm saying that either people understood nothing. I mean, it's like they're not able to relate what we've presented to their work at all. Either we were such an excellent presenters that we covered all the aspects and there cannot be any question because we explained everything. Well, I do suspect that truth is somewhere in between. But I'm giving you another 3 minutes to come with the question. And if not, we will stop the record, say you bye. We will publish the record of this session in Community Z, which means that everybody would be able to watch that. And also everybody who will have questions after the session and after the addressing of the materials, you're welcome in discussion boards. Just create the stream there, and we all are listening. We're all a part of the community, and we will answer your questions. Seems we are good. Irina, Anastasia, many thanks. It was a great presentation. And for all the audience, guys, thank you for having us here. And thank you for your time. Bye-bye.
Thank you, Sasha.
Thank you.
Thank you
everyone.
for your
Have a nice
attention.
day.
Thank you, Sasha.
Thanks, guys.